Hello and welcome back to this channel. Dear students, without wasting the time, let us start today's session. Today I will be explaining you the concept of super mesh and solve numericals which contains the super mesh. What is a super mesh or loop? Before that, if you haven't yet watched the earlier video on the mesh analysis or loop analysis, do watch it. I will provide the link in the description box. First part, what is a super mesh? A mesh or loop which is around a current source is super mesh or super loop. In a simplified language, if in a loop instead of voltage source there is a current source, that loop is said to be a super loop or super mesh. Two things you need to keep in mind. Do not apply KVL for that loop. Second, generate equation of loop current in terms of given current source. Let us solve the numerical so that this concept will be more clear to you. The question is, using mesh analysis, find current through 2 ohm resistance. This is the given network. Now, in the question, it will not be mentioned whether it is super mesh or not. You need to identify it. How to do it? Before thinking whether it is super node or not, we will mark the loop currents. We already studied that loop currents must be marked in a clockwise direction. So let us say this is one loop where I will say current is I1. This is second loop in clockwise direction where current is I2. Third loop again in clockwise direction where current is I3. Now, as far as the KVL numericals are concerned, only two rules you need to remember. If you are moving from positive to negative, plus to minus, sign is minus. If you are moving from minus to plus, sign is plus. Okay. How to identify whether it is super mesh or not? Very simple trick. There are three basic loops. You just have to observe in which loop there is a current source. In loop 1 there is a current source. Wherever there is a current source in that loop, it is a super loop. So, in case of super loop or super mesh, do not apply KVL for I1 for loop 1. Then what to do? Directly from loop 1, you can generate one equation. How to do it? Look at the loop current. In loop 1, I have marked loop current as I1. Through the current source, I1 will pass like this. That means it is in the same direction as that of I1. So directly I will generate one equation. I1 is equals to 1 ampere. Very simple. If suppose the direction of current would have been in downward direction, that means suppose it is 1 ampere but the direction is like this, how would we have written the equation? Very simple. I1 is always in clockwise direction, it is in opposite direction, so I would have written I1 is minus 1 ampere. Presently it is in the same direction, so I1 is 1 ampere. For remaining loops, there is no current source in the loop. In loop 2 there is a voltage source, in loop 3 there is no source, so we can apply KVL for loop 2 and loop 3. Now let us generate equations of KVL for loop 2 first. So I am considering loop 2. While generating the loop equation, first mark the polarities according to the direction of current. So through 1 ohm, the current I2 is moving like this from left to right, so I will mark plus minus. Keeping in mind that current always moves from positive to negative, so current I2 through 1 ohm is moving from LHS to RHS, so plus minus. These polarities are given in the question, keep it as it is. We are not writing anything for this. There is no resistance, then for this 3 ohm, sign is plus minus, because for 3 ohm current is in upward direction. Now, how to generate the equation? One more thing, after marking the polarity, you need to write the equation of voltage drop. How to write the equation of voltage drop? Basic formula of voltage, V is equals to I into R. I is current, R is resistance. So using this formula, you need to write the equations of voltage. So let us start from this point. You can start from any point, but you need to come back to the same point. So I am talking about loop 2. If we start from this point, this is plus minus. Plus to minus is minus, so first I will write minus sign. Just looking at the polarity. Value of resistance is 1 and current passing through this is I2 as well as I3. But these two currents are in opposite direction. So I2 is from left to right, I3 is from right to left. So current passing through 1 ohm can be expressed. This minus sign I have already written. Value of resistance 1. It is I2 minus I3. Why not I3 minus I2? Because if you are in loop 2, give priority to loop current I2. So it is I2 minus I3. This is about 1 ohm. Then plus to minus sign is there. Look at the convention. Plus to minus is minus. So I will directly write value minus 5. Here you don't have to consider the current because it is already value of voltage. There is no resistance. Then come back to this point. Plus to minus. Minus sign. Value of resistance is 3. Now again through this 3 ohm, two currents are moving. One is I2 and another is I1. I1 is in downward direction. I2 is in upward direction. So I will write this as I2 minus I1 is equals to 0, because we have started from this point and we again come back to the same point. Now important part is that if you want to reduce the convention, make it more simple. We have already written I1 is equals to 1 ampere. So wherever I1 is there, put this value I1 equals to 1. Then why I have written I2 minus I1 for this? Because we are in loop 2. So give priority to loop current 2. So it is I2 minus I1. So I will simplify this equation. It becomes minus I2 minus minus become plus I3 minus 5 minus 3I2. Then this minus minus become plus 3 I1. I am putting value of I1, that is 1. So 3 into 1 is equals to 0. Let us simplify it further. So it is minus I2, this minus I2 and minus 3I2 can be combinedly written as minus 4I2 plus I3. I have combined these two terms. This minus 5 and plus 3. 3 into 1 becomes 3. It becomes minus 2. But constants are transferred to the RHS. So it becomes plus 2. This is say equation number 2. So equation is minus 4I2 plus I3 is equals to 2. This is equation number 2. Same way I have to apply. What I did, I have applied KVL to loop 2. Now I have to apply KVL for loop 3. Again, before writing the equation, let us mark the polarities for loop 3 according to the direction of current. So this is plus minus because through 5 ohm current I3 moves from left to right. Then this is plus minus, current I3 flows like this. This is plus minus because again current I3 flows from right to left for 2 ohm. Okay, so for loop 3, we will write the equation here. Loop 3. Start from any point, but you need to come back to the same point. Let us start from this point. So plus to minus, you need to assign minus sign. So it is minus 5. Value of this current is I3. So minus 5 I3. Next, for 1 ohm, plus to minus, give minus sign. Value of resistance is 1. For 1 ohm, two currents are moving, I3 and I2. So simply we can write I3 minus I2 because now I am writing equations for loop 3. So I have to give priority to loop 3. So it is I3 minus I2 because I3 as well as I2 are moving through 1 ohm and they are in opposite direction. I3 flows like this whereas I2 is flowing in opposite direction. So minus 1 I3 minus I2. Then come back to this again plus to minus. So I need to assign minus sign. Value of resistance is 2. Because I am moving from plus to minus, so check the rule, plus to minus is minus, value of resistance is 2. Through this 2 ohm, again two currents are moving, I3 is like this and I1 is in opposite direction. So I need to write I3 minus I1 equals to 0. Why I3 minus I1? Same rule. I am in loop 3, so I must give priority to loop current I3. Then wherever you are getting I1, put this value without fail. It will simplify the calculation. Value of I1 is 1 ampere. So I will simply put here I1 as 1 ampere. Let us simplify this equation. So minus 5I3 minus I3 minus of minus become plus I2 minus 2I3 minus minus become plus 2 is equals to 0. Let us write in the standard format. Standard format means this equation now contains two unknowns, I2 and I3. So first term must be I2, next will be I3, and constant should be at the RHS. So equation becomes I2. Then this 5 minus 1 minus 2. It is minus 8I3 is equals to minus 2. Say equation number 3. Now what we have to do? Without thinking, we need to first generate the values of I1, I2 and I3. Out of that, we have already calculated the value of I1, that is 1 ampere. So you need to solve equations 2 and 3 on the calculator. You will get the values of I2 and I3. So after solving these equations, the answers will be I2 is equals to minus 0.4516, I3 is equals to 0.1935. We have already discussed that value of I1 is equals to 1 ampere. At the starting of numerical itself, we have discussed this part. Now what is asked in the question? Using mesh analysis, find current through 2 ohm. Look at this diagram. Through 2 ohm, which currents are moving? I1 and I3. They are in opposite direction. Through 2 ohm, two currents are moving. This current is I1 and this second current is I3. They are in opposite direction. So I need to consider either I1 minus I3 or I3 minus I1. So how to select? Either I1 minus I3 or I3 minus I1. Look at the values. I1 is 1 ampere, I3 is 0.1935. So appropriate equation will be I1 minus I3 because I1 is having larger value. So always and always larger value minus smaller value. So final answer will be I, that is current passing through 2 ohm, is equals to I1 minus I3. So simply put the values of I1 and I3. So if I will put the values of I1 and I3 and if I will solve this current will be 0.8065. In the bracket, this unit is amperes. In the bracket, you need to assign the direction. How to assign the direction? What I did, I1 minus I2, that means I have given priority to I1 because I have done the calculation I1 minus I3. So final direction must be according to the direction of I1. Look at this diagram. Through 2 ohm, I1 is moving from left to right. So I have drawn the arrow from left to right as per the direction of current I1 which is passing through 2 ohm resistance. So this is the final answer. Let us solve one more numerical, some different numerical to get the idea in detail. The next problem is using loop analysis, find V0. V0 is the voltage which is mentioned in the question. This is the given diagram. Without thinking whether it is super mesh or not, let us apply the basics. There are 3 loops, 1, 2, 3. So I will mark loop currents naturally in clockwise direction. This is say I1. This I am considering as loop 2, I2. This I am considering as loop 3, I3. You can say this is I3, this is I2. It will not make any difference. Now, after marking the loop current, we have to think in which loop current source is there. Just by observing, we will come to know that in loop 1, there is a current source. Value of current source is 4 milliamperes. That is 4 into 10 raised to minus 3 amperes. One more thing. All the values of resistances are, this is again 1 kilo ohm. So all the values of resistances are in kilo ohm. So that is 1 kilo ohm means 1000 ohm. Now, this is a current source. So in loop 1, current source is there. So directly for loop 1, I have to write equation of loop current in terms of current source. Look here, I1 is moving in the upward direction where this current source is connected. It is in the same direction as that of given current source. So simply I will write I1 is equals to 4 milliamperes. That is equals to 4 into 10 raised to minus 3 amperes. This is for loop 1. Then loop 2. In case of loop 2, again, this type of symbol, diamond shaped symbol, is known as a dependent source. Inside this symbol, if arrow is there, it is a current source. See, as far as KVL is concerned, we are not interested whether it is dependent or independent. Rule remains same, but it is a current source. Arrow indicates it is a current source, so it is again a super mesh. So as per our rule, look at the source through which this loop current flows. Loop current again flows in the same direction. So for this, I will write the equation for loop 2. I will write the equation as I2 is equals to 2ix because I2 loop current is moving in the same direction as that of given current source. Value of given current source is 2ix, so I have written I2 is equals to 2ix. Now keep in mind that you don't have to increase the number of notations. Try to reduce down the number of notations. See, ix is the new notation. Look at the diagram. Where ix is marked? Ix is marked in this branch. Through this branch, which loop currents are marked? I1 and I3. So let us simplify it from the beginning itself. Ix is downward. Through this branch where Ix is marked, two loop currents are moving, I1 in downward direction, I3 in upward direction. Since Ix is marked in downward direction and I1 is also in downward direction, so I will write it like this. Ix is equals to I1 minus I3. Very simple. What I am doing, I am expressing Ix in terms of I1 and I3. See, Ix is downward, I1 is again downward through this branch where Ix is marked, and I3 is in opposite direction, that is in upward direction. So Ix is I1 minus I3, where we know the value of I1 4 into 10 raised to minus 3. So simply I will put this value in equation of I2. So I2 is 2 in the bracket value of I1. I1 is 4 into 10 raised to minus 3, 4 into 10 raised to minus 3 minus I3, because it is 2Ix and I have simply put the value of Ix. Therefore, I will get I2 is equals to 8 into 10 raised to minus 3 minus 2I3. This is the value of I2 which I got. Let us give some equation numbers. This is equation 1, this is equation 2. Now we have to apply KVL for loop 2. So before applying the KVL for loop 2, as per the normal rules, we will mark the polarities for loop 3. So it is plus minus. I am considering this direction of I3. Then plus minus through 2k ohm, I3 flows in downward direction. Then through this branch 1 kilo ohm, it is plus minus. As per the direction of I3, I have marked the polarities. Let us write the equations of KVL. Start from this point. You can start from any point. If you start from this point, we are moving from plus to minus. Plus to minus is minus. So first I will write minus sign. Then value of resistance is 1 kilo ohm, that is 1000 ohm. Value of resistance. Through this resistance, which currents are moving? I3 is moving from left to right and I2 is moving in opposite direction. So since I am writing it for loop 3, I have to give the priority to I3. So it is I3 minus I2. I3 minus I2 for this 1 kilo ohm. Then for this 2 kilo ohm, it is plus minus. Plus to minus is minus sign. Minus value of resistance 2 kilo ohm means 2000, and current flowing through this is only I3. So it is I3. Then come back to this. Again plus to minus. Plus to minus is minus sign. Minus value of resistance is 1000. Then through this branch, two currents are moving, I3 and I1. I1 is moving like this. I3 is in upward. I1 is in downward. So I will write it as I3 minus I1 is equals to 0. Now, wherever you are getting the values, the terms I2 and I1, you need to put the values. I2 is this value and I1 is 4 milliampere. So let us put the values. So before that, I will simplify it. Minus 1000 I3 plus minus minus become plus 1000 I2 minus 2000 I3 minus 1000 I3 minus minus become plus 1000 I1 is equals to 0. Let us combine the terms. There are three terms related to I3, so it becomes minus 4000 I3. I have simply clubbed the terms related to I3. Remaining terms 1000 I1 and 1000 I2. So let us write it like this. Plus 1000 value of I2. I need to put this value. So it is 8 into 10 raised to minus 3 minus 2 I3. I am putting value of I3. Then remaining term plus 1000 I1. I need to put the value of I1. I1 is 4 into 10 raised to minus 3 amperes is equals to 0. I need to further simplify this equation. So it becomes minus 4000 I3. This is 1000 into 10 raised to minus 3 gets cancelled, plus 8 minus this 1000 is as it is, minus 2000 I3. For first term it gets cancelled, for second term it will be as it is, minus 2000 I3 plus 4 is equals to 0. So simple calculation, minus 6000 I3 plus 12 is equals to 0. From this you can well write the equation of I3. I will write it over here. Therefore 6000 I3, rather minus 6000 I3 is equals to minus 12. I have transferred 12 at the RHS. Both sides contains minus sign, so it becomes plus. So I am neglecting it. So I will get I3 is equals to 12 upon 6000. This is the value of I3. Unit is amperes. So value of I3 will be 2 into 10 raised to minus 3. This is the value of I3. We have got all the values, that is I1, I2 and I3. Now what is asked in the question? Calculate voltage V0. Voltage V0 is the voltage drop across 2 kilo ohm resistance. So use the basic equation. We know the basic equation. V is equals to I into R. R is 2 kilo ohm. What is the current flowing through this branch across which V0 is connected? This current is I3. So I will simply write V0 is equals to I3 into 2K, that is 2000 ohm. Put the values. So V0 is I3, value of I3 is 2 into 10 raised to minus 3 into 2000. Therefore V0 is equals to 4 volt. This is the final answer. So dear students, that's it for today's video. I have covered different types of numericals. Keep in mind, while applying super mesh, you need to observe the position of current source. So thank you very much for attending this session. Thank you.